Today, we are going to learn how to determine a relationship between two variables using simple linear regression. And in this case, we will study how the age of a track affects its maintenance cost. So, in a bus and logistics, understanding such a relationship, it is very crucial because it helps managers to predict the future maintenance expenses, budget accurately, and even decide when to replace old tracks and so on. We will use the data provided for 10 tracks. You can be able to see that we have all the tracks running from track A all the way to track J, and there are 10 in total. So we use the data provided for 10 tracks, showing their ages in years. That is ages in years. Showing the ages in years, and the annual maintenance in thousands of shillings in this column. That is. So our main goal will be to develop a linear regression that shows how maintenance cost depends on the track age. And then the part B of this question, we are going to also to determine, or you are going to use the equation 1 or the data that you have been able to obtain in equation 1 to estimate the expected cost for a track of a given age, let's say 8 years. So let us start with the part A. We are asked to determine the regression equation of maintenance cost on the age of the track. So we are asking, we determine the regression equation of maintenance cost, and in our table you can easily see that we have 3 columns. The first column is the track column. The second column is our X column, which is represented by the age of track in years, whereas the third column is for maintenance cost in thousands of shillings, which is our Y column. So our question says that determine the regression equation of maintenance cost, meaning they have started with the maintenance cost. They have not told us that you are supposed to determine the regression of Y on X or the regression of X on Y. But the question directs us where you are supposed to start, because we are being told that we determine the regression equation of maintenance cost. Our maintenance cost is this Y column on the age of the track. The age of the track is our X column. So in short, they are asking us, we determine the regression equation of Y on X. And the regression equation of Y on X, it is given by the regression equation of Y on X is given by summation of Y equals NA plus BX, B summation of X, that is, and the second part is summation of XY equals A summation of X plus B summation of X squared. So these are the two equations we usually use when it comes to determining the regression equation of Y on X. Now, for us to be able to know the kind of columns that we need to have in our table, what we need to do, because here we have summation of Y, and we know the summation of Y, it is obtained by adding all these elements, on the Y column. Immediately we add all these elements, or these values, they give us summation of Y. Once we add all these values on the X column, they give us summation of X. So in this particular case, here we are not going to have another column for Y, because we have it as a maintenance cost. Then from there, our N here, it represents the number of tracks. N represents the number of tracks. Then we have summation of X. Summation of X is obtained by adding all the elements on the X column. Then from there, we don't have XY combined, because our question here, you can easily see that we have X alone. Immediately we add all these values on the X column, they give us summation of X. Once we add all these elements on the Y column, they give us summation of Y. But we don't have any column whereby we have x and y combined. So what you are going to do, the first column that you are going to add beside the table that we have, we are going to have, or let me say this, we need to have x column, we need to have y column, of which we have the x column, which is represented by the age of track in years. The second column is going to be the maintenance cost, that is our y column. And then from there, we need to have a summation of xy, that is meaning you are supposed to have xy combined, because the moment you are going to add all these values on this particular x column, we are going to get what we call summation of x. Once we add all these values on this y column, they will give us summation of y. So meaning in our formula, this summation of y, it is this one. Now summation of x here, it is this one, and it is also this one. Then summation of xy, we are going to obtain it on or once we add all these values on the xy column. So meaning if you are going to add all these values, they are going to give us summation of xy. So meaning if you are going to have this column, the answer that you are going to get here, you are going to substitute here. Meaning we have now been left with only x squared. So what you need to do, we need to have x squared column. The moment you are going to add all these values, they are going to give us what we call summation of x squared. And once we have all these values, we are going to substitute them in this formula of ours, and then from there we are going to work it normally, and we are going to be able to get these constants, which is a and b, and then from there we are going to use them when it comes to computation of linear regression of y on x. So without wasting much time, let us now work it out. So here we have x column, and we have y column, we have xy, and then we have x squared. So what you need to do, we need to fill this table, and xy, for us to be able to find this value, we need to take 4, we multiply by 25, because it is x times y. So this is x column, we multiply by the y column. So xy, so here you have 4, you multiply by 25, obviously it will give you 100. Here we have 5 times 30, it will give you 150. 35 times 6, it will give you 210. 10 times 45, it will give you 450. This one is going to be 40. This one is 10, 0. 11 times 24, supposed to be 264. 12 times 50, it will give you 600. And the last one, we have 6 times 30, obviously it is going to give you 180. And as I've told you some few minutes ago, that the moment you are going to add all these values on the x column, they are going to give you what you call summation of x. So if you add 4 plus 5 plus 6 all the way to 6, you are going to get 57. And if you add all these values on the y column, they are going to give you what you call summation of y. And if you take 25 plus 30, 30 plus 35 all the way to 30 here, you're supposed to get 274. And then on the xy column, for us to be able to find to get the summation of xy, we need to add all these values on the xy column. If you take 100 plus 150 plus 210 all the way to 180, obviously you're going to get 2004. And the last column is for x squared, meaning you're supposed to take these values of x, and then from there you square. So here it is just the same as taking 4, you multiply by 4, so it will give you 16. 5 squared, or 5 times 5, it will give you 25. Here we have 6 squared, 6 squared, it will give you 36. 10 squared, it is going to give you 100. 2 squared, that is 4. 1 squared, that is 1. 0. This is 121. This is 144. And the last one is 36. If you add all these values, obviously they are going to give you summation over x squared, and the total is 483. So we are able to fill this particular table. Let us now proceed with our equations. And I told you that for us to be able to determine the regression of y on x, I have given you two formulas, and we have said summation of y equals na plus b summation of x, and the second formula is summation of xy equals a summation of x plus b summation of x squared. Now, because we have summation of y here, we have summation of x, it is here, summation of xy, it is this one, and then summation of x squared, it is this one. Now we are going to substitute them. So summation of y here, we are going to take it as a 274. Then we equate to n, of which n, I told you n represent the number of tracks in this particular case. So if we add 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or we take the original question, which is this one, we can be able to see that we have 10 tracks starting from track A all the way to track J. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So meaning our n is 10, which is 10. So this one is going to be 10a. You add summation of x, in this particular case it is going to be 57. So here is you write 57, and then from there you insert this b. Let us now proceed. The second part is summation of xy, and summation of xy, we have it as summation of xy, we have it as 2004. We equate to a summation of x. Summation of x is 57. Then we insert our a there. Then you add b summation of x squared. The summation of x squared, we have it as 483. Then we insert b. So as you can be able to see on this particular question, these are two functions, they form what you call simultaneous equations. So let me rearrange them so that you can be able to solve this simultaneous equation, either using substitution method or elimination method, or maybe like the formula that you are good at it. So this one, it is the same as writing 10a plus 57b is equals to 274, and then part B we have 57a plus 483b is equals to 2004. So allow me to use elimination method, and by elimination we usually try to do away with one unknown so that we can work on the remaining unknown. So in this particular case, I can decide to insert this particular bracket there. So this 57, because it is on the second equation, I write it here 57, and this 10, let it come here. This is 10. So 57, I have taken it here, and 10 on the equation 2. So this 57 will multiply all these elements on the first column, and 10 I'm going to use it to multiply all these elements on the second function. So 57 times 10, it will give you 570, and then you insert a. Then you add 57 times 57, it will give you 3249, and then you insert b equals 57 times 274, it will give you 15,618. 57,618. Let us now go to the second one. 10 times 57, obviously it will give you 570, and then you insert a. You add 10 times 483 to give you 4830. B equals 2004. You multiply by 10, it will give you 20,040. 20,040. Now I need to insert a sign here, and this sign will help me to eliminate either A or B. So if I insert negative there, meaning 570 minus 570A, obviously it will give me 0. So 3,249 you minus 4,830, it will give you negative 1,581B. Then we have 15,618 you less 20,040. Obviously it will give you negative 4,422. Let us now proceed. We need to find now this unknown, which is B in this particular case. So we have negative 1581B equals negative 4422. So I need to do away with this negative or these numbers so that I can be able to remain with B on the left hand side. So what I need to do, I need to divide by negative 1581. I need to divide by negative 1,581 on both sides. So on the left hand side, I'm left with B, which is if I take negative 4,422 divided by negative 1,581, it will give me 2.7969. So this is the value of B. So and in our equation we need to find the value of A. So for us to be able to find A, we need to do this. We need to take this B, and then from there we insert either in equation 1 or in equation 2 so that we can be able to find A. So let us use the first equation, which is 10A plus 57B equals 274. So where there is B, I'm going to replace with this one. So we have 10A plus 57, open the bracket, 2.7969 So we have A, and then we have A and we have B. So meaning the original equation for finding the regression of y on x, it is given by y equals a plus bx. We have been able to find the value of A as 11.657. Our A is 11.657, whereas our B we have been able to get it as 2.7969. 2.79696. So let us substitute so that we can be able to get the regression equation of y on x. So our y is going to be A, which is 11.657. Then you add B, which is 2.7969x. So this is the regression equation of y on x. it is y equals 11.657 and yeah, now we have been able to get the regression equation of y on x, and our questioner asked we are being told in our question that we are supposed to determine the regression equation of maintenance cost on the edge of the track. So that is our regression equation. Then part B of this question we are being asked using equation 1 above estimate the maintenance cost when the age of the track is 8 years. So we are asked to estimate the maintenance cost when the maintenance cost is 8 years. So in this particular case, what we need to do, because we have our question here, or our regression equation here, which is y equals 11.657, what we need to do, we are supposed to, it is just the same as saying we estimate the maintenance cost when x is equals to 8. So with our equation we have it y equals 11.657, then you add 2.7969. Where there is x, you do what? You replace with 8. Here we had x and then we have substituted with 8. So y is supposed to be 11.4573. You add 22 because 2.7969 times 8 it will give you 22.37568. So once you add these you will get 33.83. And because in our question we can be able to see that the values on y column, they were rounded off to the nearest thousands. So what you need to do, we need to multiply these value that you have been able to get here by 1000. So meaning the maintenance cost is supposed to be Kenyan shillings 33,830. So that's how you solve the two equations. So the regression equation, part A, the regression equation of maintenance cost on the edge of the track, we have it here is y equals 11.657 plus 2.796x, whereas part B, we are asked to, using equation 1 above, estimate the maintenance cost when the age of the track is 8 years. So you have substituted where there is x with 8, and this is the answer. So that's how you're supposed to solve that question. So in case of any question, feel free to attach it on the comment section or to drop it on the comment section, and I respond to you. Thank you so much for your time. Thank you.